on number 3, it says go to the picture in the box at the top of the page, and using your protractor measure all the angles in the picture. It's going to ask you what you notice about them. So if you measure all of these angles in the picture, you're going to notice a few things. First of all, I need to point out that the lines are parallel. To show that lines are parallel, I want you guys to put little arrows on the lines, because that's going to be the notation for parallel. Or you can put like a double arrow and a double arrow. That shows that those lines are parallel, kind of like double ticks. So when you look at this picture, you're going to notice that you have 2 different measurements only in the picture, like 67, 67, 67, and 67. That's one measurement. And the others are 113, 113, 113, 113. So that's one thing I notice is with all 8 angles, I actually just get 2 measurements total. The second thing I want you to notice is if I look at these as little pods, I already know what these are if I find one angle. So like 67, I know vertical angles are congruent, so that's 67. I know linear pairs are supplementary by the linear pair postulate or supplement theorem, so that makes 113. So now I can go all these. But notice that this pod's angles match this pod's angles. And why would that be? And that's because the lines are parallel. So even though our lines don't have to be parallel, like this, these angle pairs still have the names even if your lines are not parallel. But if your lines are parallel, then all of this stuff becomes a little more interesting because we get angle pairs. So down here, what I would say that I notice is there are 2 different angle measures, and the angles in the top pod or the top group match the angles in the bottom group. So it asks you after that, do you think it would be possible if you know one of the angle measures and you know the lines are parallel, that's key, your lines have to be parallel, would it be possible for you to find all the other 7 angle measures without using your protractor? And the answer is yes. You wouldn't even need your protractor to do this. If you know one angle, then you can find all the other 7 angles. And that's because when parallel lines are cut by a transversal, the angle pairs that you just learned, they have a relationship with each other. So we're going to go talk about that special relationship. So flip your page over. So this is the same picture we just had. So I'm just going to copy my measurements here and show you how if you know one angle, you can find all of them. So let's say angle 2 was 67 and I gave that to you. Vertical would be 67, linear would be 113, linear would be 113. Now notice that if I come down here and I measure angle 5, that one's going to be 67, 7's going to be 67, 8's going to be 113, and 6 is going to be 113. So again, you only have 2 different measures in the entire picture. And that's because our lines were parallel. So you can put arrows on there to show that the lines were parallel. So from those angles, we're going to come up with some theorems and postulates based on this picture. So I would like you guys to look for a set of corresponding angles. Okay, there are 4 different pairs in the picture. I'm just going to pick number 2 and 5. And notice what you can see about 2 and 5. If 2 parallel lines are cut by a transversal, then the corresponding angle pairs, they will be, each pair is congruent. So this is a new postulate that we're going to be able to use. It's called the CA postulate eventually, but we're going to call it the corresponding angles postulate today. All right, let's look at a pair of alternate interiors. All right, so let's look at like 4 with 5. Those are alternate interiors. What do you notice about pairs of alternate interiors? If your lines are parallel, they will also be congruent. Now we're going to look at a pair of alternate exteriors, and you can pick any pair you want. Alternate exteriors would be like 1 and 6. 1 and 6 are alternate exteriors. What do you notice? They're going to have the same measures also. So they, if your lines are parallel, they will be congruent. Now all this is happening if your lines are parallel. It doesn't work if your lines are not parallel. That's called the alternate exterior angle theorem. Now we're going to look at the consecutive interior angle theorem. Okay, so let's look at consecutive interiors. So something like number 3 and number 5 would be consecutive pairs. Oh, are those congruent to each other? No. So if you got going too fast and you wrote congruent for all of these, stop right now and erase this. This should say supplementary. So consecutive angles are not congruent. They are supplementary if, again, you have parallel lines. So you got to have parallel lines first. Now look at a pair of consecutive exteriors. So we're going to compare something like 113 for number 1 and 67 for number 7. Those are consecutive exteriors. Those are not congruent, so if you went too fast, erase. This is supplementary. Now, our book does not talk about consecutive exteriors, but we will use them in class because I like to, because they're easy to use. So that's the consecutive exterior angle theorem. Okay, so now we're going to use this postulate and these theorems, and we're going to answer a few questions to practice. So we're going to do number 1, and then you'll go back and try number 2. Okay, so let's say that they tell you that angle 2 is 4x plus 7. So I'm going to label this 4x plus 7. And they tell you that angle 7 is 5x minus 13. Now, the very first thing I want to do is ask myself, are these lines parallel? Because if they're not, I might as well quit. So look for the little arrows. That means that the lines are parallel. Golden, they are. So now I'm going to ask myself, what kind of angle pair is that? So sometimes it helps to turn your paper around. This is the transversal. And these are on opposite sides of the transversal on the outsides of the parallel lines. So opposite side, outside. So now what I know is that these are alternate exteriors. These are alternate exterior angles. Okay, so what happens to alternate exteriors if your lines are parallel? Let's go up and look at our theorem. The alternate exterior angle theorem says if two lines are parallel, then your alternate exterior angles will be congruent. Great. What that means is that these angles will be congruent. So what we can do is set 5x minus 13 equal to 4x plus 7. I know the angles have to match because of the theorem above. Now we're going to solve. Bless you. So we're going to subtract 4x, and we're going to get x minus 13 equals 7. We're going to add 13. X equals 20. So now we know that x is 20. Now, it's going to ask you to justify why you think this. So I know they're alternate exterior angles, so I come up here and I look at the name. It's called the alternate exterior angles theorem. So I'm going to complete this. It's the alternate exterior angles theorem. And that is the reason why I know they're congruent. We're going to be using these in proofs, which is why I'm having you do that. So we're going to skip 2, and you will go back and do number 2 over here in just a second, and we'll check it. Okay, flip it to the back. I'm going to do one more example with you. So it says in this picture that G is parallel to H. So we're going to put arrows on G and H. I'm going to do 1 and 1. And then it says M is parallel to K. So I'm going to put double arrows on M and double arrows on K. So that shows that these two are parallel. So I have 2 sets of parallel lines. All right, we're going to skip down and do number 5, and then you're going to go back and do number 3 and 4 and then check your work. Okay, so they would like you to look at 13, angle 13 is 13y minus 10. So I'm going to put that right in my picture. 13y minus 10. And then they want you to take angle 14 and put in 6y. So go to angle 14 and put in 6y. So now we have to ask ourselves, what kind of angles are 13 and 14? And that's going to help determine what we do with them. So if you look, those 2 angles sit up against this transversal M, right? So now we have to ask ourselves, are they on the same side of the transversal or the different sides? They're on the same side of the pink line. And are they inside or outside the G and the H, which are the other lines that are intersected? They're on the inside. So we call those consecutive interiors. So now what I'm going to do is I'm going to go find the name of the theorem that I'm using. Oh, it's called the consecutive interior angles theorem. And what it says is, as long as my lines are parallel, those pairs will be supplementary. Notice it doesn't say congruent, it says supplementary. So we're going to come back over here, and we are going to add up these angles and set them equal to 180. And the reason why we're allowed to do that, we'll write it in a second, is the consecutive interior angles theorem. Okay, now we're going to solve this. So that's 19y minus 10 equals 180. 19y equals 190, y equals 10. So our y is 10, and the reason why, not the letter y, the reason why is we were allowed to use the consecutive interior angle theorem. And that's what allowed us to say that they were supplementary. So that is going to be the reason why, and then that's allowing you to find your variable. Okay, so you guys are going to go back and try the ones we skipped, and then we're going to check them.